Hello viewers, Logarithm taking you through the story of A-level applied mathematics. And this video I'm going to go through the topic of linear interpolation and extrapolation. So this topic is under numerical methods and is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So this topic is for linear interpolation and extrapolation. So let's first talk about linear interpolation. So this deals with computation of values that lie within, this word, within given values, as the word inter suggests. So by that you can easily know what extrapolation means. Extrapolation means that the value required is outside the given range, and inter means the value required is within the given range. So if we desire to find information or locate a value which is not tabulated, so this topic will involve values which are tabulated and they ask you for a certain value which is not within the given table, but it is known that the value lies between two successive values x1 and x2 which are already in the table. The method of linear interpolation is often employed to approximate or locate the value. So before anything, let's first look at the progress of our coverage. So this is the progress. Like we said, mechanics is divided into three parts. One is kinematics, and in it you expect one question in section A, one question in section B from this, and this is so the ones which are ticked are the topics which have so far been covered. The ones which are half ticked, it implies that they are those very topics which we uploaded first when you had just opened the video, when you had just opened the YouTube, and by that time the quality was not that okay, so plans are being made to remake these videos. So the part of dynamics, also one question in section A, one question in section B, and these are the topics and these are the progress. Statics, one question in section A, one question in section B, and these are the topics and these are the progress. Then statistics and probability, that is 3 questions section A, 3 questions section B, and this is the progress. Now we are on numerical methods, so we shall first concentrate on numerical methods until all these 5 topics are done. So far we already covered errors and trapezium rule, and now we are going to cover linear interpolation and extrapolation. After that we shall cover root location and approximation, and lastly we shall cover flow charts. So we are going to consider a function, say y equal to fx, with two known values being x1 y1 and x2 y2 as shown in the sketch below. So we shall first draw our axes, then from there we shall show our function y equal to fx. So we have two known values x1, and that is point A with coordinate x1 y1. Then also we have point B with coordinates x2 y2. So these values are known. Now suppose we want to find the corresponding y value of a point whose x coordinate is x0. So the value will be here, but we don't know that point yet. We don't know that point, and we also don't know that this function. If we knew this function, we will just substitute this x0 into this to get the corresponding value of y. But under linear interpolation and extrapolation, this function which was used to get these values, to generate these coordinates, is not given, so there's no way we can do that. So what do? We draw a straight line, just like the word linear means. So draw a straight line from here up to here to join these 2 points. Then the point you can get from linear interpolation, like we said, numerical methods is mainly concerned with approximate values. So linear interpolation is going to give us this point C as our y0, but the exact point which they want, the exact value they want, is this one. But since linear interpolation or numerical method is about approximating, what we do, we can use the method to get a value which is just closer to the exact. So numerical methods, we can't get exact values, we get approximate values. So that is why you see this value which you are getting is somehow deviating from the exact value. Now the question is, how do we get that approximate value? What we do, now that we know this, we have drawn this straight line, we are going to complete a triangle, and then we remember the knowledge of similarity or knowledge of gradient. So similarity, that is geometry, shows that EC from here to here or divided by DB is equal to AE divided by AD. I think you remember that knowledge of similarity in O level. So when we use that, we know that this C, the coordinate is x0, y0, then A, the coordinate is x1, y1, and B, the coordinate is x2, y2. So what we are going to do, we shall get this length CE. Now the length CE is from here up to here, so it will be y0 minus y1. Then the length DB is from here up to here, so that will be y2 minus y1, as you can see it here. Then AE is from here up to here, so the length is x0 minus x1, which is this. Then AD is from here up to here, and the length is x2 minus x1, which is that. So basically this is the formula of interest which you use to get the approximate values. Remember, we get approximate values under numerical methods. So another one is linear extrapolation. So this one is also similar to the one to linear interpolation, only that this time the value is outside, as we shall see in the sketch. So linear extrapolation, on the other hand, is employed when values lying outside the given data are required. Know this word, outside. Therefore, if we desire to find information or locate a value which is not tabulated, but it is known that the value lies outside, so lies outside the given data, but closest to the values, not this word closest. So this word is very vital. Closest, we shall see how it is used. So closest to the values x1 and x2, the method of linear extrapolation is often employed to approximate or locate the root. Not this word that what we get is an approximate value. So we don't numerical methods, we use methods which can give us approximate values. So that should stick in your mind, because every topic under this main topic of numerical methods deals with getting approximate values. So just like we did for linear interpolation, here we are going to also consider a function y equal to fx with two of its known values being x1, y1 and x2, y2, as shown in the sketch below. So we shall draw the axes, and then we show the function y equal to fx. Then we have two coordinates x1, y1, which is that, and also a coordinate of x2, y2, which is that. So we are interested to get a value x0, but this value, I think, realize that it is outside this given range. So that is why we call it extrapolation. Previously it was within the given range, so it was called linear interpolation, but now we call it extrapolation because it is outside the given range. So what we do to get that value, we draw a straight line joining these 2 points from here up to here, and I think realize that the value you are going to get in this using linear extrapolation is this y naught, and this y naught is somewhat deviating from the exact, because the exact value is this, but the one you're going to get using this method is this. So always remember that we get only approximate value. So this value you're going to get, it will be an approximate value but closer to the exact. So what do? We still complete a triangle, and then we use the knowledge of similarity as we used in linear interpolation, and we shall get the same formula as we got before. So the formula for linear interpolation and linear extrapolation is the same. Now the arrangement that you can choose to change the arrangement. For example, you can, if I want to use gradients, I will say this over this is equal to this over this. Therefore, that means that these values, I can bring it this side, and I also take this value this side. It is still okay. Though for me, I prefer that we put all the y values on one side and the x values on the other side, so that we can easily make one variable the subject, as we shall see in the examples. So that is all we need to know under linear interpolation and extrapolation. So next we are going to go through a number of examples so that you can easily grasp the concept. So we shall start with question 1, which came from UNEB 2020 paper 2 question 2, that is last year, and it says the table below shows the values of x and the corresponding values of a function fx. So these are the values of x with their corresponding values of fx. Like I told you, here they don't give you this function. Otherwise, if they gave us this function, we would just substitute to get these required values, but in this case they don't give you. So that's where the method of linear interpolation comes in. So they said use linear interpolation to find fx when x is 0.4. Then part B, use linear interpolation to find x when fx is 3.82. So the first thing to do is to locate the two values which enclose this required value. So 0.4 is between 0.3 and 0.6. So what we are going to do, we are going to extract out these values and add another table in between them which has x equal to 0.4. So let's do that. So what you have done, you have extracted out this value and these values, and in between them you have put this value which was given, and this one is unknown. So we are going to use the linear interpolation to find this value. So first of all, you have to remember the formula, that the formula is changes in y equated to changes, ratio of changes in y equal to ratio of changes in x. For example, I'm going to say this. So if you look at this value and this value and this value, it is this one which is smaller than this. So what we are going to do, when you're using getting change in y, you're going to say this minus this divided by this minus this. So that is why you see here y minus 3, and you see here 3.22 minus 3. Then when you get that, we are going to equate it to the corresponding change in x. So changes in x, still we do the same, because for y we started with this minus this. Even in x we are going to start with this minus this. Then for y we say divide by this minus this. So that means that even for x we are going to say divide by this minus this. That is why you see here 0.4 minus 0.3 divided by 0.6 minus 0.3. Now after stating that, the next is to look for a way of making y the subject. So when I make y the subject, what I'm going to do, this one 0.4 minus 0.3 gives me 0.1, 0.6 minus 0.3 gives me 0.3, 3.22 minus 3 gives me 0.2, and this 3 is the size. So my aim is to make y the subject, and when I use a calculator I'll come up with 3.0733, as simple as that. So basically that is what they wanted in part A. So when you go to part B, for part B they want the value of x when fx is 3.82. So 3.82 lies within this and this. So what does that mean? It means that you are going to extract out these values, and in between them we shall add a column of having where fx is this. So let's do that. So these are the two values in the table, but we were given this value and this one is unknown, and it's what we want to get. So since we want to get x, it means that we are going to start with, in our ratio, we are going to start with changes in x and equate them to changes in y. So still what you do, you compare this value and this value. It is this one which is smaller, therefore when you're getting your ratio you'll say x minus this 0.9 divided by 1.2 minus 0.9. Then for changes in y you will still do the same. 3.82 divided by 3.82 minus 3.69 divided by 4.06 minus 3.69. I think you can see that's why there is this one here and this one there. Then this one is there and this one is that. So after that, the next thing to do is to make x the subject, and that is all they want. So when I make x the subject, you realize that the whole of this gives you 0.13, and the whole of this gives you 0.37, and the whole of this gives you 0.3, and this one comes here. So when I use a calculator, I'll come up with 1.0054, and basically that is what they wanted. So this B1 is for extracting out the suitable values from the table, and M1 is for the substitution, A1 for output, M1 for substitution, A1 for output. So that was question 1. Now we shall go to question 2. Question 2 came from UNEB 2019, paper 2, question 6, and says the table below shows the commuter bus fares from stage A to stages B, C, D, and E, as you can see it here. Then part A, Jane boarded from A and stopped at a place 2 kilometers after E. How much did she pay? So 2 kilometers after E, it means that it is outside this range. So what we are going to do, when it is outside, just know that it is now extrapolation. So you look for the value, the two values which are closer to this value, and the values closer are these stages D and E. So what we are going to do, we are going to extract out these two values and add another column outside them, for which corresponds to this 2 kilometers, 2 more kilometers. So 2 more kilometers means that it will be 23 plus 2, which is 25 kilometers. So here we're going to extract out the values. So this is the value which is required. So still we are going to use the linear interpolation. So for these two, for the part of y, this one and this one, it is 2200, which is smaller. So what you are going to do, when you're getting the ratio, it will be y minus 2200 over 2500 minus 2200. Then for the x, you could do the corresponding one, so it will be 25 minus 19 divided by 23 minus 19. So that is why you see this one here and this one here. Then you see this one here and this one there. So after that, next is to look for a way of making y the subject. So the whole of this, the whole of that is equal to this, and the whole of this is equal to that. Then this one is there. So when you calculate out, it will be shillings 2,650. So basically that's what they wanted in part A. Now let's go to part B. So part B, they said Okello paid shillings 2,000. How far from A did the bus leave him? So what you're going to do, you are going to look for where 2,000 lies. So 2,000 is between C and D. So we are going to extract out these two values of C and D, and in between them we shall put a column which has 2,000 for fares. So after the extracting out the values, we are going to use linear interpolation. So 16 and 19, it is 16 which is smaller, so our ratio will be x minus 16 divided by 19 minus 16 over, equal to 2000 minus 1700 divided by 2200 divided by minus 1700. So that gives you that. So when I make x the subject, x will be equal to 17.8 kilometers. So basically that is what they wanted. So M1 for this table, extracting out the suitable values, and M1 for substitution, A1 for the output, M1 for substitution, A1 for output. So that was question 2. Now we shall go to question 3, which came from UNEB 2018 paper 2 question 3, and says the table below shows how t varies with s. So this is t, this is s. Use linear interpolation stroke extrapolation to estimate the value of t when s is 26. So when s is 26, 26 is between this and this. Therefore, we are going to extract out these values and be able to come up with what is required. So when you do that, this is what you're going to get. So after that, we shall use linear interpolation, changing t over changing s. So changing t to this one and this one, you look at the one which is smaller. The one which is smaller is negative 2.9. So we are going to say that our ratio will be t minus negative 2.9 divided by negative 0.1 minus negative 2.9, as you can see it here. Then do the same for the part of s. So it will be 26 minus 30 divided by 20 minus 30. So after that, next is to make t the subject, and that will be the required value. So next they want the value of s when t is 3.4. Now 3.4 is between 3.4 is actually outside here, so the closest values are 2.9 and 3.1. So what you are going to do, we are going to extract out these values, and we shall add another column for which has 3.4 as t. So that we shall look at these two values. There is 9 and there is 12. So when you are making our ratio, it will be s minus 9 divided by 12 minus 9. Then up here it will be 3.4 minus 3.1 divided by 2.9 minus 3.1. Then next is to make s the subject, and s will be equal to 4.5. So basically that is what they wanted. So B1 for extracting out suitable values here, M1 for substitution, A1 for output, M1 for substitution, A1 for output. So that was question 3. Now we shall go to question 4. I think realize that now the only knowledge is the knowledge of similarity, the formula we derived under interpolation and extrapolation. So basically that is all, but we are going to do a number of examples so that you can easily grasp the concept. So question 4 came from UNEB 2014, paper 2, question 6, and it says, given the table below, so these are the table, use linear interpolation to find y when x is 16. So 16 is between 10 and 20, so we are going to extract out these values and we add a column in between which has 16 as a value of x. So what you are going to do for y, we compare this 2.9 and negative 0.1. It is negative 0.1 which is smaller, so we are going to say y minus negative 0.1 divided by 2.9 minus negative 0.1 is equal to 16 minus 20 divided by 10 minus 20. So when you do that, we shall come up with that. So after that, the next thing to do is to make y the subject, and y will be equal to 1.1. Then we shall now go to part B. Part B, the one, the value of x when y is negative 1. So negative 1 is between negative 0.1 and negative 2.9. So we are going to extract out these values, and in between them we shall put a column where the value of y is negative 1. Then after that, we shall compare for x, we shall compare this 20 and this 30. It is 20 which is smaller, so we shall say x minus 20 divided by 30 minus 20 is equal to negative 1 minus negative 0.1 divided by negative 2.9 minus negative 0.1. So when we do that, we shall come up with that step, and when we make x the subject, x will be equal to 23.2143. So basically that is what they wanted. So B1 will be for this, M1 for this, A1 for that, B1 for M1 for that, A1 for that. So that was question 4. Now we shall go to question 5, which came from UNEB 2012, paper 2, question 7, and says the table below shows the cost y shillings for hiring a motorcycle for a distance x kilometers. So this is the table. Use linear interpolation or extrapolation to calculate part A, the cost of hiring the motorcycle for a distance of 45 kilometers. So 45 kilometers is outside the range, so it is here. The closest values are these ones, so we are going to extract out these values. Then we shall add another column whose value for distance is 45. Then from there we shall compare these values of y, this one and this one. It is this one which is smaller, so we are going to say that y minus 4,400 divided by 5,200 minus 4,400 is equal to 45 minus 30 divided by 40 minus 30. So when we do that, we shall come up with that, and when we make y the subject, y will be equal to shillings 5,600. Then part B, they said they want you to find the distance Mukasa traveled if he paid shillings 4,000. So 4,000 is between this 3,600 and 4,400. So we are going to extract out these two values, and in between them we shall add a column whose value of cost is 4,000. So next we shall see that this and this, it is this one which is smaller, so the ratio will be x minus 20 divided by 30 minus 20 is equal to 4,000 minus 3,600 divided by 4,400 minus 3,600. So when you do that, you shall come up with that. And when I make x the so this value should be x. So when I make x the subject, x will be 25 kilometers. So put x here. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for this, M1 for this, A1 for that, M1 for this, A1 for that. So that was question 5. Now we shall go to question 6, which came from UNEB 2011, paper 2, question 3, and says the table below shows delivery charges by a carrier company. Using linear interpolation or extrapolation, find part A, delivery charges for a parcel weighing 352 grams. So 352 grams is between 200 and 400. So what you are going to do, you are going to extract out these two values, and in between them we shall add a column whose value for grams is 352. So at this, we shall look at these values of y. This one which is smaller is 700. Therefore, the ratio is going to be y minus 700 divided by 1200 minus 700 will be equal to 352 minus 200 divided by 400 minus 200. So when you do that, we shall come up with this part. Therefore, making y the subject, y will be equal to shillings 1080. Then part B, they said find the mass of a parcel whose delivery charge is shillings 3,300. So 3,300 is outside this range. So what we are going to do, we are going to extract out these values and add another column whose value for charges is 3,300. So next I look at these values of x. It is this one which is smaller, therefore the ratio is going to be x minus 400 divided by 600 minus 400 over will be equal to 3,300 minus 1,200 divided by 3,000 minus 1,200. So we come up with that, and when I make x the subject, x will be equal to 633 and a third kilograms. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for extracting out suitable values, M1 for substitution, A1 for output, M1 for substitution, A1 for output. So that was question 6. Now we shall go to question 7, which came from UNEB 2009, paper 2, question 3, and says the table below shows the distance in kilometers a truck can run with a given amount of fuel in liters. So L denotes liters. So these are the values, and they said estimate part A how far the truck can move on 27.5 liters of fuel. So 27.5 is outside this range. Therefore, what you're going to do, we are going to extract out these values and add another column here whose value of fuel corresponds to 27.5. So next we shall compare these values of x. It is 33 which is smaller, therefore when I'm getting the ratio to be x minus 33 divided by 42 minus 33 over 27.5 minus 21 divided by 24 minus 21. So when we do that, we shall come up with this. Therefore next is to make x the subject, and x will be equal to 52.5 kilometers. Then part B, the side estimate the amount of fuel required to cover 29.8 kilometers. Now 29.8 is between 28 and 33, therefore we are going to extract out these values, and in between them we shall add a column whose value for distance is equal to 29.8. So in this case 13 and 21, it is 13 which is smaller, therefore the ratio will be y minus 13 divided by 21 minus 13 is equal to 29.8 minus 28 divided by 33 minus 28. So when I make y the subject, y will be equal to 15.88 liters. So basically that is what they wanted. Now let's see how much can be awarded. So B1 for this, M1 for this, A1 for that, M1 for this, A1 for that. So that was question 7. Now we shall go to question 8. Question 8 came from UNEB 2005, paper 2, question 2, and says, in the table below is part of an extract of from sec x degrees. So these are the values. So this prime means is a symbol used to mean per minute. So it's usually used to bypass the way of expressing an angle in terms of decimal point. For example, if I say 60 prime 0, 60 0 prime, it means that 60 plus 0 over 60, which is 60.0. So it's a symbol used to bypass a decimal point. For example, if this 12 prime is the same as 12 over 60, so 12 over 60, for example, when I use the calculator, you realize that 12 over 60, let me see, 12 divided by 60, it gives me 0.2, meaning that 60 degrees 12 prime is the same as 60.2 degrees. So that prime, that is what it means. Therefore they said use linear interpolation to estimate Roman 1 the value of sec 60 degrees 15 prime. So 60 degrees 15 prime, in other words, if I say 15 divided by 60, it will be 0.25. Therefore 60 degrees 15 prime means 60.25, but in this case we don't alter what is given, so we are going to leave it as prime and we see how it is worked out. So what we are going to do, this 60 degrees is constant for all. What is changing is this part of prime. So what I'm going to do, I'll look for 15. 15 is between 12 and 24. So that means that I'm going to extract out these values, and in between them I'll add another column whose angle is 15 prime. So for these two values of y, it is this one which is smaller, therefore the ratio will be y minus this over this minus that, as you can see it here. Then for the upper part, it will be 15 minus 12 over 24 minus 12, as you can see it there. So when I make y the subject, y will be equal to that. So that implies that sec 60 degrees 15 prime is equal to 2.0153. Then Roman 2, they wanted the angle whose secant is the same as sec. Secant is 2.0436. Now 2.0436 is between this and that. Therefore, we are going to extract out these two values, and in between them we shall add a column whose secant is that 2.0436. So next we shall compare this and this. It is 36, which is smaller, therefore the ratio will be x minus this divided by 48 minus this equal to this minus this divided by this minus that. So that gives you that part. So when I make x the subject, x will be equal to 42.1417. Therefore the inverse of arcsec 2.0436 is equal to 60 degrees 42 prime. Like I said, the meaning of this prime is to bypass the decimal point, so that means that we won't add on this part of the decimal point, because this prime was used to eliminate the decimal point. So basically that's what they wanted. Now let's see how much can be awarded. So B1 is for this, M1 for this, A1 for this, M1 for that, A1 for that. So that was question 8. Now we shall go to question 9, which came from UNEB 2004, paper 2, question 3, and says, in the table below is an extract of part of log x to base 10, that is log base 10 of x, and these are the values. Then they said use linear interpolation to estimate part A, log base 10 of 80.579. So 80.579, 80.0, 80.2, 80.5, 80.8. So 80.579 is between those two values. So what we are going to do, we are going to extract out these two values, and in between them we shall add another column whose value of x is 80.579. Then we shall use our ratio. So of these two, it is this one which is smaller, so we are going to say that the ratio will be y minus this over this minus this, as you can see it here. Then our part we shall say this minus this over this minus this, as you can see it here. The next is to make y the subject, and y will be equal to 1.9062. Then part B, they said estimate the number whose logarithm is 1.90388. So 1903888, 19031, 19042. So that means that 1903888 is between these two values. So we are going to extract out these two values, and in between them we shall add a column whose value of log base 10 is of x is 1.90388. So the ratio, it will be, so this and this, it is this one which is smaller, so it will be x minus this divided by this minus that, as you can see it here. Then down to be this minus this divided by this minus this, as you can see it that side. So next is to make x the subject, and x will be equal to 80.148. So basically that's what they wanted. Now let's see how marks can be awarded. So B1 for this, M1 for this, A1 for that, M1 for this, A1 for that. So that was question 9. Now we shall go to question 10, which came from UNEB 2003, paper 2, question 4, and says, in an examination, scaling is done such that candidate A, who had originally, know this word originally, score 35% gets 50%, and candidate B with 40% gets 65%. Determine the original mark of a candidate C whose new mark is 80%. So we are going to first extract out a table having original mark and new mark. So the first one, the original mark is 35 and the new mark is 50, so we shall put 35 there and 50 there. Then this one, they want the new mark to be 80%, so we shall put 80% there and unknown value there. Then this one, the original was 40, new mark is 65, so we shall put 40 and 65 there. So next we shall use interpolation. So of these two, it is 35 which is smaller, therefore we shall say that x minus this divided by this minus this is equal to this minus this divided by this minus that. So when you do that, you shall come up with that part, and when you simplify to make x the subject, x will be 45. Therefore the original mark was 45%. So basically that's what they wanted. Now let's see how marks can be awarded. So B1 for extracting out the values, M1 for this part, M1 for this part, and M1 for equating, A1 for the output. So that was question 10. Now we shall go to question 11, which came from UNEB 2000, paper 2, question 2, and says, by the method of linear interpolation, you use the table below to find the value of Roman 1 lean 1.66 correct to 3 decimal places. So 1.66 is between these two values, so we are going to extract those values, and in between them we shall put a column whose value of x is 1.66. So next we shall realize that this and this one, it is this one which is smallest, therefore the ratio will be y minus 0.4700 divided by this minus that is equal to this minus this over this minus that. So you'll come up with that value, and when I make y the subject, y will be equal to 0.506. I remember they give you the accuracy of 3 decimal places. Then Roman 2, they want the value of x corresponding to lean x equal to 0.4000. So 4000 is between these two values, therefore we're going to extract out these values and add another column whose corresponding value of lean x is 0.4. So our ratio, this one is smaller than this, therefore the ratio will be x minus 1.4 divided by 1.5 minus 1.4 equal to this minus this divided by this minus that. So when I make x the subject, x will be equal to 1.4092. So when you don't specify the decimal points, you use 4. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for this, M1 for this, A1 for that, M1 for this, A1 for that. So that was question 11. Now we shall go to question 12. Question 12 says, a weighing machine is corrupted and a mass of 2 kilograms is recorded as 1.5 kilograms and 5 kilograms is recorded as 4 kilograms. Estimate using linear interpolation the mass that is recorded as 2.25 kilograms. So here we're going to draw a table having corrupted result and also the correct result. So here they said a weighing machine is corrupted and a mass of this is recorded as this. So this is the correct value and this will be the corrupted value. So you come and put those values there. Then this two recorded as this, it means that this is the corrupted value. Then here 5 as this, it means that 5 is the correct value and 4 is the corrupted value. So next is to use linear interpolation to be this minus this divided by this minus this is equal to this minus this divided by this minus that. So when you do that, you shall come up with that. And therefore, when I make x1 the subject, x1 will be equal to 2.9. So basically, that's what they wanted for Roman 1. M1 for this, A1 for that. Then Roman 2, they want the mass that is recorded accurately. So recorded accurately means that this corrupted value is the same as this correct value. That is when it will be recorded accurately. So shall come here So those are the values. I think we'll say that accurately means that the same values. The corrupted value is the same as the correct value. Therefore, when I use linear interpolation, I'll get that, then cross multiply, or when I simplify, this gives you this, and when I cross multiply, I'll come up with that. When I collect like terms, I'll come up with x2 equal to -1 kilogram. So that's what they wanted. Now let's see how much can be awarded. M1 for substitution, M1 for cross multiplying, A1 for the output. So like I said, we are working on a project where I want to change our hard copy books into video lessons. So this math 2, the math 2 content is good from this book and also from the UNEB Question Bank. I think you realize that most of our questions come from the UNEB Question Bank. So these copies are available. You can contact the author on these contacts. So you also have math 1, that is where the content for math 1 comes from, and from that question bank. Then you also have physics 1, that's where the content comes from, and physics 2, that's where the content comes from. O-level, that is senior 1 and senior 2, and this is for senior 3 and senior 4. This is sub-math question bank, so sub-math content. Then A-level question bank and O-level question bank, they are also available, and O-level math question bank is also available. So all these books are available. Therefore, if you want any of these books, you can contact the author on these contacts. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on root location and approximation. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on root location and approximation has been uploaded. Otherwise, if you know any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.